Okay, welcome back to the answers for the homework the other night. You can pause this video and look at these answers, all you need to look at in order to see what you need to see. And at the end of this video, I'm going to go over just a couple problems I thought you might have questions on. If you end up having questions on more of these problems, then that's a really good time to use our Google Meet to ask questions or ask to see how some of these problems are worked, or to say, hey, I did it a different way. Can you look this over? So pause the video as much as you need. All right, so let's take a look at the ones that I thought you might have questions on. Again, pause the video as much as you need. Actually, let's take a look not at this one, but at this one. So this set of problems in problem 3 dealt with a pretty complicated drawing, and I thought, hey, there might be some people out there who kind of really struggled with this. Well, one of the things that we talked about is trying to look for relationships by using colors to make those relationships pop out. Now, I hope everybody saw that there's one triangle in this picture, but there are a bunch of parallel lines. And if you use our trick of coloring parallel lines the same color, you will see a bunch of relationships pop out. So for example, I noticed that right here we have 130 degrees, and we know that vertical angles are equal. So right away, boom, I get angle A is 130 degrees. I also notice that this blue and red angle, and this is a blue and red angle. And if I can identify the name of those two angles, I can get the relationship. And of course, the name for these two angles is they share a vertex, they share a side, they're called a linear pair. And so this angle right here would be 50 degrees. And I'll lock that in as 50 degrees. Now, here's a blue and red angle. Let's go back to our original blue and red angle. Do these angles have a special name? Well, they don't share a vertex, so they're not linear pairs, they're not vertical angles. But they do have parallel lines. And these two angles are both to the left of the red line and to the right of the blue line. So that puts them in the same position, which makes those two angles corresponding angles. You also could use these two angles. They are alternate interior angles. So we know this is 130 degrees here, and of course it's vertical with this F, so that's 130. Or the original 130 degree angle, you could say, is a alternate exterior with F, or this 130 degree angle is corresponding with F. So we could move these angles all over the place. Now, down here we have a red and blue angle. What's its relationship with the original 130 degrees? Well, these are both corresponding angles. Same position to the left of the red line, above the blue line, just a different location. Or you could say that this 130 and that 130 are alternate interior. How about this D? Well, this letter D has no name or direct relationship with the original 130 degree angle, but it is corresponding with this 130 degree angle, or it's corresponding with that 130 degree angle, or it's alternate interior with that 130 degree angles. So we can work our way all around these blue and red angles just by knowing our vocabulary. H. Well, H, blue and black. Here's a blue and black angle. Notice they share a vertex, and they are backdoor angles. So these are vertical angles. I can put 25 degrees there. How about K? Well, this 115 degree angle is corresponding with that angle there. And you'll notice these two angles right here are a linear pair. So if we take 180 and we subtract 115, we get 65 degrees, which can go right here. And of course, if this is 65, this should be 65 because they're vertical. And a nice way to check all of this is if you look at this triangle right here, you know that all these angles have to add up to be 180 degrees. So that's how we might attack that problem. Okay, so now let's take a look at this problem here, which I thought several of you would want to see worked out. Now, this problem is going to take a lot of interaction with the picture. Let's start with perimeter in this case. So the perimeter, we're going to add up all the sides. And this first side is countable. 1, 2, 3, 4, 5, 6, 7. And this side down here is also countable. And that's 7. So the perimeter, I have 7. I have a slanted side, which is not countable. I have 7 again. And then I have another slanted side, which is not countable. So how do we find those slanted sides? Well, we're going to have to find these lengths indirectly. So if I come down here, I can form a right triangle right there. And two sides of this right triangle are countable sides. This first one, 1, 2, 3, 4, 5. And this second one, 1, 2. And so I can find this missing side right here using the Pythagorean theorem. 5 squared plus 2 squared equals that unknown side, I'll just call it empty box squared. And if we do the math, 5 squared is 25, 2 squared is 4. We can find the length of that unknown empty box, and it turns out it's going to be the square root of 29. Now, I don't know what the square root of 29 is, although I know it's got to be between, 5 and 6. So that's how long the perimeter is. And when I go ahead and I get out my calculator and I just dump that whole thing into my calculator, I get that the perimeter is about 24.77. Let's just call them units because I don't know. Oh, and by the way, I knew this was radical 29 because you'll notice this is also 5 by 2. So that was the perimeter. It involved some work, and notice, I interacted with my picture, I wrote down the Pythagorean theorem, and I kind of wrote out a plan of attack. Now for area, I would love to see you write the formula, and we know it's a parallelogram, so I know the area equals the base times the height. And so I'm going to look for a right angle. And it just so happens that I made a right angle when I was finding the perimeter. So one side of the parallelogram is the base, and that will be 7. And the height is the other side of the right angle. And you'll notice the height of this is a countable distance. It's simply 5. That's what we found right here. The height is 5. So that means the area is 35, and let's just say square units. So those were the two that we really wanted to highlight. If you have questions that weren't answered or you can't figure out looking at the answers, please use the Google Meet, talk to us, and get the help you need.